Okay, so I want to do a little bit of housekeeping first. I am a big fan of accessibility and including everyone. So I just want to say that I do have images in my slide deck. They are mostly decorative, but if they add any context, I'll explain them. And then I do have links to the slide. It's a bit.ly link, bit.ly/Stanford -get -into -groove, because I do have links in the slide decks to more information. And at the end of the presentation, I'll post that, but I'm not in the position to copy the link right now. Let's see, my name is Amy June. I am currently the community manager for opensource.com, but more, I'm a Drupal core mentor. I believe in really reducing the barriers to entry. And so that's why I like to give these kind of beginning Git talks. Oh, and I wouldn't be me if I didn't introduce where I am speaking from today. I am in Hollister on Ohlone lands. And I just want to acknowledge that colonialism is a current and ongoing thing. And we need to build our mindfulness about our present participation in that colonialism. Usually go by Volkswagen Chick across all of the media. I was a Volkswagen mechanic in a previous lifetime. So that's where I got that name from. And then Spot, actually it's not Spot, it's Luna. She's right here. But I like to say that if there's any typos or anything wrong with the presentation, it's because my cats helped me program it. You know, they like to lay on the space bar. So what we'll talk about today is we'll go a little bit about, you know, how we're freelancers or beginners, or, you know, maybe we're contractors, and how we move into maybe working for an agency or a consultancy. And one of those things that we might want to talk about is version control. So I go into get branches, get commands, and then I talk about get clients, because there are command line things that you can do, but sometimes as a beginner, or sometimes depending on your role, maybe command line isn't right for you. So learning how to do it in a client is helpful. And then I talk a little bit about local environments. So moving to agency from freelance has its advantages, but you know, there's reasons why we do really enjoy working in freelance. We love the freedom, you know, we work on our own time at any time of the day, right? But that freedom can be hard because there's no one to bounce ideas off of, no one to help you with code review. Sometimes you do what you have to do to get the job done, you know, and sometimes having little or no accountability can be detrimental. I used to equate it to like the wild, wild west, right? When you're freelance, you're juggling all the roles sometimes. You know, you're the person in charge of everything. You're the project manager, you're the developer, you're QA, you're user experience, you're the person, you're the code reviewer. So many of the advantages that freelance work had historically has been encompassed into agency life now, you know, with the onset of the pandemic, which I just learned ended today. Like all of a sudden, one day it's over. So, but with the onset of the pandemic, companies are moving to more remote friendly, and they're really becoming more inclusive of time zones, which is spectacular. And teamwork offers diversity of thought and creativity. A team environment allows everyone to brainstorm, in turn increases problem solving, and we arrive at solutions more effectively and more efficiently. You know, effective teams also allow the initiative to innovate, you know, in turn creating a competitive edge. Team effort increases output by having quick feedback, or multiple sets of skills come into play to support your work. You no longer have to be have skills in everything. You can play to each other's skill sets, you know, really honing in on your own. You can do the stages of designing and planning and implementation more efficiently when there's a team functioning with you. And working in that traditional full-time web development role at an established company or agency or consultancy can give you the opportunity for structured learning, plus everyday exposure to mentors, to experts, to best practices that you most likely won't get when you're a freelancer. At least not without making the effort to track them down yourselves. And sometimes motivation can be a key, or lack of motivation can be a key point in why we don't learn things when we're on our own. So when you're on your own, you assume every role. On a team, there's a place for everyone, to contribute based on the role and the skill levels. And again, that really adds to the accountability and that forms of checks and balances. On a team, we have project managers. They help assign tasks and they act as sort of the in-betweens between the developers and the product owners or stakeholders. They help translate technical jargon and really kind of hone in and find out what is specifically needed. Tickets are created and submitted and assigned. Developers or designers work on the tasks and then collaborate, which leads to improvement and more ideas. Then there's like technical leads who help merge code and settle any conflicts in code. And then after changes and conflicts are resolved, we have people who do user testing or quality assurance or regression testing. And then, again, the project manager steps in and decides if the changes are ready for the stakeholders. And it's really this rinse and repeat. And it's so much easier on a team. So version control. Code workflow management becomes a great deal easier when we have version control. So what is version control? And, I'm going to talk specifically about Git because that's more of the modern one that we're using. There's a couple other version control systems out there, but really Git is the standardized one for most of the technologies we use these days. So version control is a system that records changes to a file or a set of files over time so that you can recall those specific versions later. And I know that's a mouthful, but really it kind of takes a snapshot in time, and those snapshots don't go away. So as people commit their code and do version control, you can go back and see what people have done and go back and change it, and really helps with transparency of who's doing what. Version control systems are a category of software tools that track a software team, that help a software team manage changes to source code over time. Again, that version control software keeps track of every modification to the code in a specific kind of database. If mistakes are made, designers and project managers can turn back time and make comparisons to earlier versions of the code to help remedy any mistakes or any blunders without a lot of downtime for the whole team or client. It really makes that unweaving process a lot easier. So what are some requirements of implementing version control? First, you need a computer equipped with the task. You need to install Git globally or locally. Sometimes if you're on a Mac, it's installed automatically. If you're on a Linux computer, you have to, do it manually. Even if it's already installed, which it may be if you have dev tools installed, it's probably a good idea to, update to the latest version. And this can be done as a package or with another installer, or you can download the source code yourself and compile it yourself if you feel confident enough to do that. So you need a computer equipped with the task. Now this is debatable. Forget, some people think that you need basic knowledge of the command line. If you're a beginner though, a Get client can be used, a graphical user interface, but you should be acquainted with some of the basic command line knowledge. Not a lot, but it really helps to know what's going on behind the scenes of the client. And again, these clients, they're graphical user interfaces for the command line, and I want to introduce this because in the next few slides, I have some images for reference. After I introduce the commands that would be used in the command line, I have a screenshot of what it might look like in a Get client. And that client really simplifies the commands into buttons, drop downs, and window interfaces for workflows. So here's a screen interface, and I'm not going to explain all of it, but you can see that there is a visual of the commits that were made. There's a panel of code diffs. There's a list of files on one side. You can see who did the commits and so much more. And I'll break this down a little bit. And there's all types of Get clients available. Some are free, some are open source, some are not free, and some are SaaS products. Some have free versions with limited access, and others are free with full access. Some free versions only allow you to work on repos that are public. So that can be limiting if your client's code bases are private or have limited access. So I really recommend folks doing their homework, try some out, make sure that they have the features that you need. And sometimes if you work at a consultancy or an agency or do some contract work, there's shared licenses because maybe they want everyone to use the same client. And IDEs, some IDEs have Get clients integrated into them. IDEs are integrated development environments, and these can help you manage workflows as well. There is a learning curve to an IDE that might not be accessible or might not be needed depending on your role. But much like Get clients, some are free, some have trials, and some, again, agencies like everyone to use the same tools. So make sure your machine can handle running an IDE. Sometimes the combination of having apps can affect runtime and really slow a machine down. I know until I started working with a stronger machine, if I had Docker open along with a complicated spreadsheet and then turned on my Slack, my machine would really start whining the fan, when I started my IDE, and then start Zoom, forget it. So why Get and not Subversion or another Get tool? And I talked a little bit about this, but just to iterate, because Get has become the industry standard for web development. It has a really rich set of commands for tracking and cloning and workflows. And many of these basics can be carried through to those other versioning workflows. So here comes some cheesy 80s references because, this is called Get Into the Groove. So we're never gonna get you up, never gonna get you down. So please forgive me. So here are some basic commands. We have Get Init, INIT. This will start a new repository. Get Status, I use probably more than any other command out there. It will list all the files that have to be committed. A good command to run before running any other command. It kind of works as a check-in of sorts and reminds you of what you've been working on. That's Get Status. Get Branch, it lists all your local branches. We don't all work on one branch. We make forks and we make branches and do our work and merge it in. So Get Branch will list all of those branches we've created. And it also visually indicates what branch you're on. In my terminal, the branch that I'm on is in a different color and usually has an asterisk by it. And then when you're in a Get client, it's usually highlighted. Get Diff shows the differences between files which aren't yet staged. Get Log, this is a command. It's used to list the version history of the current branch. Get Push is another one that we use pretty often. It sends the committed changes of your main branch to a remote repository. You may be more familiar with the term master branch, but I'm moving away from calling it that in favor of calling it main branch. Get Pull, that pulls down and fetches and merges and changes on the remote to our server. So our working directory on our machine matches what's up in space. Get Add, after you've been working for a while, this adds the files or the set of files to a staging area. And Get Commit, that's where you get that snapshot. It records and snapshots the file permanently in the version. And now it's part of the source tree. You can do all sorts of changes, but until you commit them, that's when it becomes part of the project. And then git merge. This command merges different branches into the current branch. And we'll talk a little bit more about some of these. So let's get into the groove and talk about working locally. This means on your machine and not in the browser or in the cloud. So again, working with some of these commands, I sort of breezed over. Working locally, get clone. You need to have those files on your computer, and the way you do that is you clone them from somewhere else. So get clone creates a working copy of a local repository. From there, you can set up making changes. And typically, if it's not started from scratch, you get it someplace else, and that's get remote. You know, if you haven't connected yet to your local repository or to your remote server, you add the server to be able to push to it or pull from it. So this get remote is used when you have created and initialized a code base locally. And then get pull, this is for when your code is someplace else. It might be different from your current work. It fetches it. It merges the changes onto your remote server into your working directory. And again, I'll mention a couple of these commands a few times because they're used in different workflows. It helps keep you up to date with what other work you're going on to this git pull. And here's a really cruddy screenshot. Oh, the aspect ratio is weird on this one. It's a screenshot of a get client while cloning, you know, very intuitive interface. You enter the URL of the code base where it's live and you push a button. Most repos online have this information readily available in their dashboard or README files. And so this is where you select, enter your URL, and then hit go, and you'll get those files onto your local machine. So let's talk about branching, take my branch away. We don't want to make changes to shared code. So we create branches that mirror the code and work there so we don't interrupt others' work. So I hope that makes sense. So in the perfect workflow, we have our code base, and then I'm working on one branch and Aaron's working on another branch. And that way, when we're working in the same files, we're not messing with each other's work. So that's branching. So some of the commands we use for branching is get branch. This will list all the branches in your repository and also tell you what branch you're currently in. And again, I'll do a get status or a get pull to see if there's more branches that people have been working on. Get checkout with your branch name. This command is used to switch from one branch to another. Get checkout with the flag -B. So get checkout -B will create a new branch and switch you to it. And then get branch D will delete the feature branch. So there's multiple workflows when working with branches. And back to that client, press a button and you can name the branch in a matter of seconds. How you name the branch is up to you. Go with what's best practices with whoever you're working with. Some consultancies or open source projects that you're working with might have parameters on naming conventions, like the task or a ticket number. So just make sure that you follow best practices from who you're working with. But you can see that, you can add a branch or add a branch and switch. Again, all this done in the command line with those commands we just saw before, but you can do it in the interface. So push it real good. This used to be one of my favorite cheerleading songs in college. So pushing, this refers to working with others remotely. At some point you'll want to share your modifications or share what you've been working on. So to do that, you have to push it upstream. You want to make sure your branch is ready first, though, because you want to make sure what you've been working on, all of it gets up there. So we want to commit our files. We want to add our files. We want to add one of our files to staging. So we get add. We want to get commit. Again, that commits those changes to the current branch and makes it part of that snapshot. We get pull again. because we want to fetch and merge anything that people have been doing on that remote server. And again, I reference this command a lot. It's important to make sure your work is current with others. Sometimes communication is less than perfect and people are working on the same lines of code at the same time. Maybe someone has pushed theirs up since the last time you checked. So this really helps with conflicts, which I'll talk about later. But so get pull fetches and merges changes that others have been making. And then get push, once you have all of the things merged in with what you're working on, you push those stages to the main branch of your remote repository. And here's another picture of that interface. Pushing refers to working with others remotely. So you can see up here, there's some buttons, there's pulling and syncing. You can see that there's a place for repositories. Again, most of these interfaces are pretty intuitive. Some of them are pretty accessible, for keyboard commands and using it like this. And it just makes it a little bit easier than that command line. So like immersion, requesting for the very first time. Before applying outside changes, you should get your work in good shape and committed locally so it will not be clobbered if there's any conflicts. So let's bring all of our work together. Again, there's different ways at different times that we bring our work together. And this is more than just pushing your code to a clean branch so that you're caught up to it. But maybe the team is working on the same code all at once. Again, iterating on this. It needs to come together and be merged. So get remote. Again, this command is used to connect your local repository to the remote server. Get pull. Remember, we've talked about this one before, fetches and merges the changes on the remote server to your working directory. And then get merge. This command can be scary, but this command merges the specified branches into your current branch. And this is why I really appreciate a get client, because I can see, this is a screenshot of changes that were made. So I can see what branch I'm on, what files were touched. And then in that middle section, you can see what files, what lines of code were added, which lines of codes were changed, and which lines of code were different. So it's a real nice graphical colored user interface to kind of see all of your changes, because on the command line, there's lots of pluses and minuses, and it's just not as intuitive. Again, there's buttons for everything. Here's this magical button for merging. It does the things behind the scenes and pulls the code together. And while it can do magic, it doesn't want to make assumptions if there's a lot of conflicts. And so it will actually ask you about conflicts and give you windows where you can pick which commits you want. If there's two commits that sort of conflict with each other, it lets you kind of cherry pick which commits you want to add. So let's talk about conflicts and commotion. I've seen this meme around, not sure if everyone else has, but I find it hysterical every time I see it, where the developer says, oh, it'll be a quick fix, and no, it's not. And that's how I feel about merge conflicts sometimes, because conflicts do happen, even with the most senior developers, people who have been working on the project for months. And the most direct way to resolve a merge conflict is to edit the actual conflicted file. So here's the workflow for that. We've seen some of these commands before. Get status, that will list all the files you've changed and those that still need to be committed or added to. Get diff, remember this is those differences between the states of the files. And this is useful in sort of predicting and preventing merge conflicts. here's a new one, which we haven't looked at, get log with the flag merge. This will view all the merge conflicts. And then get push, that sends those changes to the main branch of your remote repository. So here is a couple of some files that there's 3 versions of the same code compared to each other. Again, with the get client, it's really easy to kind of see those changes. This is the time to review and check. There's really 2 things you can do with this information. You can decide to merge, or decide not to merge, or you can fix the conflicts. And when the decision is made not to merge the code, because it's really not playing nice together, or it's just in such a wad that it's just too hard to manage, there's a workflow for that. So get fetch origin, fetches that latest history from the server, and you can point your local branch at it. Get reset with a specific commit. Commits have a hash or a number, but if you do get reset commit, this command actually redoes all of the commits after the specified commit and preserves those changes locally. So it's a little bit like an eraser button. And then get reset hard with your commit code or hash. This command disregards all history back to a specified commit. And there are buttons to help you with this nuclear option, push a button to reset all of the things. But what's nice is get clients over the command line. Get clients are polite. They make sure you really want to blow up or dissolve your work by asking, are you sure? That's not something you always get in the command line. So next, web-based version control. And this is what I've seen a trend in recently when we're using platforms like GitLab or Gitbucket or GitHub. These platforms provide you with a really rad visual interface, which can help you track or manage your changes and manage your version control projects locally. And they have user interfaces as well. And so the workflow with these clients like GitLab or Bitbucket is you create a branch. So you're working away from production. We don't ever want to work directly on prod. You add your commits, you revise the code and then add them to the branches. You create a pull request. And what that does is it alerts the people you're working with that you're ready for your code to be reviewed. And then the code reviewed, people discuss and collaborate. Maybe they'll revert some stuff, but this is really that space to collaborate and make code comments. And then when everyone sort of decided that this is a good way to do, we merge and we move our code into the main branch. So again, we create a branch, we add commits, we create a pull request, do code review, and then merge those all together. So here is a visual of a GitHub repository. It looks a little bit different than our Get client interfaces, but you can see across the top, you've got the name. You have some links back, some breadcrumbs to go back further into the repository. You have many of the same buttons. You have some help stuff. You have right there, if this is like a workflow, you can see the issue queue when you click on that issues button. And then, you can see all of the files that are created in this repository. And this is a GitHub pull request. Again, what did we do? We branched, we made a fork, we made our changes, and then we create a pull request where people are going to review our code. So you can see that up at the below the title of the merge request, there's a commit happening, and then there you can see how many files have been changed. And this is where we kind of look at what changes have made, do some collaboration, and decide whether or not we want to merge it into the main branch. Local servers play a vital role in development right now. The purpose of a development environment is to have a place that allows development and testing on a local machine without the concerns of maybe losing internet connection or accidentally creating security holes or constantly uploading files. It's a place for developers and designers to test anything they want without worrying that it would affect any end users or content editors working on a live site. So what are some requirements for setting up a local host? At a minimum, for Drupal or WordPress, you need a web server, a database server, and PHP for WordPress or Drupal. You again need a computer equipped with the task. You need a processor, memory, disk space. And I think these numbers change each time that our OSs get better or each time, we update our version of Linux. But typically you might want to have a 2-core 86 compact processor or 4 gigs of RAM. Probably if you're working on multiple projects, want at least 25 gigabytes of available disk space. And these are preferred, because some of the more complex agents might need more to work at their optimum level. We found that below or better to deliver the best experience. You can have an 8-core processor, 8 gigabytes of RAM, and 100 gigabytes of available disk space. But our local environments, our local tooling like DDEV or Lando or Doxel or whatever Acquia tool that you're using, they've been getting much leaner and being able to work on less memory. So do your research when selecting which service you use. And again, if you're working with a team, typically because they add specific files to our code bases, it's easier when you work with a team to have that same local environment. So a local server, like I said, provides that pivotal role. It allows development and testing. Linux, Mac OS, and Windows development, you can have a virtual machine, a virtual development environment. These are sometimes called VMs. These are like full self-containerized servers running in its own environment and operating system, which you typically share with a shared document root. So say you have a Windows machine, you can run Linux on that and have a different environment depending on things. There's Docker development environments. Docker is a great local development environment because it has a small footprint and fast startup time. But Docker isn't always open source. So if you work on projects that demand open source, parts of Docker are proprietary. So that's something to consider. But there's lots of documentation out there right now on how you can run these local environments using tools like Kalima to replace Docker if you're an open source aficionado. So making the case, why a local server? There are reasons that pretty much require you to build your web stuff locally. You have limited access to a client server. If you're building a website or app and you don't have access to their web server, you have to do it locally. If you're building a new version of an existing site or application, which means that you don't want to mess with the production code while you're tinkering and experimenting and adding new things and possibly making mistakes, and so when you're doing those feature requests, it's very convenient to do it locally instead of on prod. You might not have good internet connection. You may live where I live and it's spotty internet and you can't always depend on your internet to get you on the cloud. You're a parent and you're picking up your child from piano practice, and in the car you can do your work on your local environment. you don't need a web hosting service or even an internet connection to do this. Everything runs conveniently on your computer. So you can concentrate on coding and leave the development of the site until you're ready. You can customize your setup. You can test your development before going live. It really takes away some of that risk when building new features, making the development process less stressful. And it gives you more control, particularly when you're debugging complex issues or errors. It's sometimes helpful to have more control over your environment. You can't always change the settings on your production environment to help with debugging. And then do you really want debugging on your production where everyone can see what you're working on? So there's some good news here. Those requirements we mentioned a few slides back, the web server, a database server, and the PHP, a lot of those local hosts do all that for us. They usually come equipped with everything. They come with the web server. They come with data management system to run on a web server. They have server-side programming languages. Sometimes you can find, if you're working in Go or Java, they have options to, work in your specified language. They have an interface for controlling the web server, stopping, starting, and so on. They have lots of good help commands. Some of them have graphical user interfaces where some of them don't, are only on the command line. But typically they always have an interface for accessing and manipulating the database. And this is my last slide. And I just kind of want to mention this because this is a newer thing, and a lot of agencies and consultancies haven't embraced this yet. But there's a new exciting browser-based environment that allows for collaboration, and it's called GetPod. It's pretty straightforward to spin up an automated development environment in the cloud. It doesn't take very much time. You can use VS Code or any JetBrains integrated development environment, IDE, with the environment, and it's very customizable. And this is something Offershall is working on in the Drupal contribution space. It's called Drupal Pod, and we use that. So when people are doing contributions to Drupal now, they don't need a local environment. They can spin it up in the cloud, and they can actually share their environment with someone else, and you can see people working in their live environments right then and there. So with that, I want to say thank you. It's always a pleasure to come to Stanford Camp. And again, it's Volkswagen Chick across all of the spaces. And I do have some resources that talk about, the top 20 Get commands, some comical stuff about Get, and then some documentation. And the nice thing about Get is it's been around for a while, and the documentation is really good. You can hit help in your GUI, and you can hit help in your command line, and usually a lot of those commands will come up and kind of give you a little tutorial about how to use them. Any questions? And it's okay. I do want to plug a couple. I work at opensource.com, and so my passion is open source projects. There's a lot of Get clients available, but there's some really good ones like that are open source. That some of the open source ones can be kind of funky because they're not actively worked on, but Smart Get is a great beginner Get tool. It's kind of bare bones. It doesn't have a lot of the bells and whistles, but I like it for beginners because it doesn't have a lot of the bells and whistles. You can kind of learn what you're doing as you're doing it. It says it'll have like a tooltip, like, oh, this is what you want to do. This is what it's doing behind the scenes. So you're able to like learn Get at the same time while using the interface, and that's Smart Get. And Source Tree is another good one. Yeah.
There's a question in the chat. If you could post your slides in the chat.
Oh, yeah. So what I'll do is I will stop sharing and grab that link, because I don't want to go to the beginning and give anyone like visually induced motion sickness going through all my slides.
Also, I can take that URL and post it to the session page.
Okay. Oh, hi, Tara. Oh, I guess bit.ly doesn't expand. Can you copy and paste that? Maybe I'll open it up that way. We can have the whole thing. I know Zoom has changed its settings on what it will unfurl. So here's the actual documentation, the doc link. You're welcome, Tara. You're welcome, Melissa. And Get is something that can seem overwhelming at first, but once you get the hang of it, and again, like using that Get client and learning what's happening behind the scenes will help you like do it on the command line too, and it's not so scary. And you know, a lot of commands you'll never use, you know, and so sometimes like taking the time to learn the more advanced commands doesn't make a lot of sense until you need to do them, because by the time you use them again, you've forgotten why you used it. So something to think about. But there's about 20 basic commands that are really handy, and I have those in that last slide of resources. Okay, great. Well, thanks, Erin, for having me.